Hi all. In this video we're going to look at one of our first weather systems, and we're going to look at depressions. Now, to get us started, what actually is a depression? What do we mean by that term? Now, very simply, it's a low pressure weather system. Now, by low pressure we're talking about low air pressure, and it occurs where we've got two different air masses that meet. Now, if you look down at this diagram here, the red kind of triangle I've got here is meant to represent a mass of warmer air that is kind of moving its way across a mass of cooler air or cold air. Now, we've got two boundaries here. You know what I mean? This one here, and then we've got this one running down here. Now, the name that we give to the boundary between the two air masses is a front. And when we talk about depressions, we've got two main fronts that we deal with, where we've got the leading edge of the warm air. So if we imagine that this mass of warm air is moving from left to right, the leading edge of the warm air we refer to as the warm front. The leading edge of the cool air behind this air mass we refer to as the cold front. And then we've got a third area, that the actual area of warmer air in the middle here we refer to as the warm sector. Now, there is going to be a lot of terminology in this video, guys, so it will be worthwhile kind of pausing it and reviewing it, but we will look over it in detail in class as well. Now, if we move on from here, what actually happens at the different fronts? So at the warm front, first we've got warm air begins to rise up over the cooler air. As it rises, it begins to cool. Now, cold air, or cool air, can hold less water vapour than warm air can. That means the water vapour begins to condense into water droplets, which then go on to form clouds. Now, the first clouds that we see form are the very, very highest clouds that we ever actually see, and they're called cirrus clouds. Now, let's take it from there. Now, I'm going to show you a couple of animations in this video that demonstrate what happens as a front moves from left to right. Now, a point that's important to say here is that the view of the image you had on the previous slide was an idea of a top-down, a bird's eye view, a plan view. The view that you're going to get in the next couple of slides is in cross-section. So for the next few slides, we imagine that we can actually see the Earth's surface alongside us. So let's have a look at these and let's see what happens along the warm front. So we've got our warm front, we've got some dense cool air, and the area we have here is our warmer air. Now, the warm air is forced to rise up over the denser cooler air. Because of this, as it rises, it cools. The water vapour forms clouds, and the high-level wispy clouds that we get are called cirrus clouds. Now, in here you can maybe very faintly see some kind of dashes there, and that's meant to indicate these clouds. Now, it's also worth saying at this stage that I know the background has changed to this kind of slightly yellowish colour. It's just very much just to make these animations a little bit more visible. Now, that's what happens to the air as we move along the warm front. What else is happening here? So if we think about precipitation, our air is still moving up, it rises, it cools. We've got our cirrus clouds, but clouds that are a bit lower are going to form slightly differently, and we start to get cumulus and nimbostratus clouds. Now, what is important to note about these clouds is that they give steady, prolonged rain. So if you were to be stood here, you're going to be in the rain for quite a while you wait on this whole system to move across. As this whole system is going to move from left to right. So if you're initially stood here, over the period that the depression lasts, which as a rule is normally a number of hours, you're going to experience all of the weather that we talk about. Pardon me, guys. So in summary, we've got some cirrus clouds up at the top. They're wispy. First clouds that we're going to see as this front approaches. We're then going to get some nimbostratus clouds and some cumulus clouds, which are going to bring prolonged rain at the warm front. And this all happens because the moist air, the warmer, moister air, rises up over this, along the warm front, over the cooler air, and as it rises, it cools, condenses, we get clouds. Now, if we move into the warm sector, now the warm sector occurs between our warm front and our cold front. The air that we get inside there, we tend to see a lot of condensation, and we get some stratus clouds. Now, stratus clouds are kind of like a big blanket of clouds. So if you've ever, and you've all seen all of the types of clouds that we're going to talk about. But stratus clouds are when you look outside and it seems like there's just clouds that go on forever. That's stratus clouds. So it's very, very overcast, and while you tend not to get particularly heavy rain, showers are particularly common when you're in the warm sector. So again, if we have a look at this, now I'm bringing in the cold front here so we can see the entire system. We see that warm air is rising up above the cold air on either side because the cold air is more dense, so that forces the warm air to rise. And that means, and I'll go back a slide, and that means that in this whole area we're going to start to see showers develop as this warm air rises. The moisture in the air condenses as it cools, we get clouds, and then we're going to see some showers. Now we've brought the cold front in here, so our cold front's off at the side here. What's happening here? So along the cold front, and we're bringing in some mention of some of the kind of specific air masses here, but the cold maritime polar air moves faster than the warm air. It's also denser than the warm air, and as such, it undercuts that warm air, forcing it to rise pretty quickly and aggressively. So the water vapour begins to condense into water droplets. These begin to form extremely tall clouds, and these clouds are called cumulonimbus, or storm clouds. So if we have a look again, here's my warm sector over at the right here, and let's bring my cold front in. So it's coming in, it's moving quickly, it's undercutting this warm air, forcing it to rise. As it does so, it's rising rapidly, and that's going to make my clouds form. As my clouds form, let's say they're large cumulonimbus clouds, storm clouds, we're going to see heavy rain, possibly thunder and lightning. And that's what's going to happen along the cold front. Now, that's a rundown of a lot of information. What I want to look at for the last couple of minutes of the video is some other ways that you're likely to see this information portrayed to you. Now, what we've got on the screen at the moment is something that's called a synoptic chart, sometimes simply called a weather map. Now, if we look here, the kind of blue area we've got here, this is all just cool air, or cold air, and the pink area I've got in the middle is my warm air. So this air mass is likely to be my maritime polar air mass, and this is likely to be my maritime tropical air mass. And this whole system is going to move across from the west, from out in the Atlantic, and it's going to move across the United Kingdom in this direction. It's also very common for this system to spin this way as we go up. So it's going to spin anti-clockwise. Now if I do a wee comparison here, this is to show you how looking at it in plan view, in bird's eye view, relates to looking at it in a cross-sectional view. So again, here's my cold sector, my area of cool air, which is this whole area here. Then I've got my warm sector, which is in here, so this is where I am directly, the warm air is directly above me. And then as I go further this way, I'm back into the cold sector. Now a couple of things that are worth pointing out here. You'll notice here that it's saying, okay, hang on, the warm front is extending up this way. It doesn't look like that's happening on the plan view diagram. Now it's not, and what we need to remember is that this plan view diagram is 2D, it's a map, it's a flat shape on a desk. We can't represent some of these 3D models as elegantly as we would maybe like to. But as this warm front approaches, you are going to start to see cirrus, cirrostratus, altostratus clouds all appear. You're then going to move into cumulus and nimbostratus clouds here, and as the warm front itself passes over you, you're going to start to experience that steady rain that we talked about earlier. Then as the warm sector is going over you, you're going to have stratus clouds, this big blanket of clouds, and you're going to have showers for the period of time that is passing. Then, on comes the cold front, big cumulonimbus storm clouds formed there, heavy rain, thunder and lightning's possible as well, and that's going to be with you for a relatively short period of time, and it's going to move off, and you might have, like we've got down here, you might have kind of remnants of some smaller clouds that have been formed, giving you little bits of showers, but eventually you're going to return to the same position you were at right at the start, where you've got the same air mass overhead and the same weather conditions. Now, there's only one other thing that I want to show you all in this video, and it's this same diagram, but it's a very, very useful table that outlines the different weather conditions that you experience at different areas as a depression moves over you, and it gives you an idea of the types of information that you're going to need to discuss when you're talking about this as an exam question. So we look here, you've got examples of the different cloud types that you would experience at different areas along the depression. Similarly, what is rainfall doing? What is the precipitation going to be doing? Now it is worth noting that dependent on time of year, our drizzle and rain may well be sleet or snow. Now the temperatures here obviously aren't meant to be an absolute dyed-in-the-wool. It will always be 3 degrees Celsius when you are at this part of the cold sector, but it's to give you an idea that as you go from the cold sector into the warm sector, funny enough, it gets a little warmer. And then as you go from the warm sector out back into the cold sector, the temperatures decrease again. Now we've also got an indication of what our wind direction is doing, and finally we've got an indication of what's happening to our air pressure. And as we can see here, we start over here, so we've got high air pressure which is falling, 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 then it steadies out as we reach the heart of the depression in the warm sector, and then it begins to rise back to whatever we would consider the normal level for that time of year. And this is why we call this a low air pressure system, because it's defined by falling air pressure. Now, there's been a lot of information in this video today, guys. This is a challenging concept. This is one of the things that people do find tricky to get their head around. So take your time with it, rewatch the video in places if you feel the need, and we'll discuss this one further in class. And until the next video, I'll see you guys later.